I want to talk about my favorite R word. Woo, YouTube algorithm, don't worry, that word is reuse. I mean, let's face it, of the three R's, reduce, reuse, recycle, it's the most fun and the one that's most in your control. You can't reduce how many iPads exist, and recycling them is a dubious proposition at best. Sure, you can recycle them, but who knows what happens to some of that stuff. A large chunk probably ends up as a sea turtle's hat. I have this stack of 3rd and 4th generation iPads, but they're all iCloud locked. If only there was some way to turn them from a paperweight into something useful again. There are two parts to this project. The first part is figuring out how to plug a computer into an iPad display. That's the easy part. So easy, in fact, that it's already been done. Gen 3 and Gen 4 and probably other iPads use embedded DisplayPort for their displays, which is basically just DisplayPort, so there have been adapter boards for this for a while. You just buy one of those and plug it in and you're good to go. And for most people, it would stop there, but I'm insane. Spiraling down the hellhole that is iPod Nanos, it just wasn't enough pain. And so I want to make this a touchscreen too, but like, how hard can it be? It's already a touchscreen. Maybe this will make sense if I explain how multi-touch on an iPad works. The iPad screen is made up of a bunch of rows and columns of capacitive sensors. There's a chip that sends voltage through rows and a chip that reads columns detecting touch. The data is processed and sent to another chip which does more processing and sends the final touch data to the CPU over a protocol called SPI. And that's it. To start this project, I just want to eavesdrop on the multi-touch data with a normal iPad to prove that this project can actually work. First thing you do is you gotta open up the iPad. You do that with heat, and you do that with guitar picks, and you do your best not to break anything. Make sure you test it. That's kind of weird. You shouldn't be able to do that normally. Then you take out the logic board, and then you block the camera shot while you try to solder all 3 wires to it. But then you put the logic board back in. Hey, it's working. There's some data. Well, it's not data. It's the clock signal. But hey, here's data. Can't wait to see what this all means. Just kidding. I already know what it means. But yeah, this took me a couple days to actually write and implement. I skipped over a lot, but hey, guess what? It works. Well, the most trivial solution works. You can get the touches that are being touched, that are being read by the Raspberry Pico off the SPI line, but that depends on the iPad being on and iOS being fully booted, which can cause problems down the line, like when the screen turns off, the multi-touch turns off, and that's bad. But I need to get there without the CPU running or iOS running at all. My theory is that I can just feed 3.3 volts into the 3.3 volt rail that the touch system depends on, and it'll just work. Wrong. What? What Tucker doesn't know is he's about to embark on another dark voyage that will consume every free moment of his life for weeks. Hey, so you'll never guess this. It actually turns out that it's a whole lot more complicated than I initially thought at the beginning of the video. Why don't you look surprised? So we have a few problems we're going to have to solve to get this to work the way I want it to. Sorry, I look a little different. It's been a while since that last clip. We want to be able to use the touchscreen hardware without the A5X ever doing anything, so we have to learn how to turn the multi-touch chips on ourselves. There are a few steps to this. We'll just be assuming more and more responsibility until the A5X is just in reset always and forever. This is the SPI initialization of the iPad screen. There's a lot of activity going on here. We don't have to understand what this means yet, or ever, as we'll see in a second, but take my word for it when I say that this is calibration data and firmware that the iPad uploads to the multi-touch system every time the screen is turned on. Let's go into some boring nerd detail to get a firm understanding of how this all actually works. The iPad multi-touch system is made up of 3 chips. One chip sends signals down the rows of the screen with specific timing, and one reads the signals from the columns of that screen. That chip ships the data over to the chip that we care about, the BCM5974. Now, this is a pretty interesting chip. Basically, it's an ARM chip that runs custom firmware, processing raw touch data and interacting with the A5X, while the upstream chip is able to push unprocessed touch data using a specific protocol that allows it to read and write arbitrary memory without the intervention from the ARM core, like some sort of external DMA. Here's the patent that describes it. This is important to understand because this is the mechanism that's used by the iPad during initialization. It uses the same arbitrary memory protocol to send that calibration data and firmware, execute it, and then uses some switching logic in the circuitry to communicate with that code over another SPI interface. So that's what we have to do, or at least that's a start, but how do we get that data? While the firmware blob ships with iOS, the calibration data likely comes from the factory and may be different for each screen. It's stored in system configuration on NAND, and NAND and I aren't really on speaking terms at the moment. But it's all right here. Can't I just use this? What if the mod had a training phase where it just recorded whatever was going on here and it played it back as appropriate, and we didn't have to understand a single thing about what this means? This training phase works by initializing a PIO block on the Raspberry Pi Pico that records the data. I use a DMA channel to copy it over to a buffer asynchronously. Then, whenever chip select goes low, we know a new block of data is being sent. Once we see the execute packet, we're done, and we save it to onboard flash so we can replay it later. Okay, so we've taken a big bite of the boot up process to about here. That's a big chunk, but this next few milliseconds of time cost me months. The multi-touch system needs two things to work, 3.3 volts and a 32 kilohertz clock signal. These are generated by the power management unit, or PMU if you don't have a lot of time. So we need to know how to talk to that and what to say. This gets its commands from the A5X over I2C. By sniffing that bus, we can correlate the commands with when the multi-touch system turns on. Through some trial and error, I've been able to distill it down to two. One ostensibly turns it on, and the other turns on the 32 kilohertz clock signal. But there's something weird happening. When I let the iPad turn the touch system on itself, I'm able to take over, replay the whole initialization thing, and interact with a fully booted touch system. But if I put the system in reset and turn everything on myself, then I get this invalid version number back and the whole thing just doesn't work. I tried a lot of things. My project notes span weeks without much progress, at times reading more like a crazy man with a yarn wall who knows too much about iPads, just trying to figure out why me turning it on was different from the iPad turning it on. I figured there was some bootstrapping issue with the BCM5974 or an out-of-band signal that just wasn't surfaced on the board. I poked and prodded the board for a very long time. I figured out what's been happening. Are you ready? It was the multi-touch reset line. Holding the A5X in reset probably floats that pin, and I thought that as long as I wasn't holding it low, it would be fine. And it wasn't fine, and that was the source of all of the issues. So now the Raspberry Pi Pico can hold the A5X in a reset forever, and we have complete control over the multi-touch hardware. Finally. So accomplishing this milestone does not mean that the nightmares are over. On the contrary, it means that I have to get back to the project and actually try to do what I set out to do. This digression, while important, took way too long. So there's still a lot I have to do. Like the board is still in the background of the shot. I haven't put it back into the iPad yet. I also have to figure out how to get the actual display port signals from the plug to the screen. I know at the beginning of the video, which I'm sorry, seems like ages ago, I said that there were adapter boards for that. But as I was kind of thinking about it and going through it, I realized those adapter boards, they won't fit. Yeah, so here's the board. Touchscreen goes in here. Display goes in here. Here's the adapter board that I got from Japan. Here's where the display goes. It's designed to roughly do this. Now, you might already see the problem. I don't know what to do about that. We'll come back to that, but for now, let's see if the touch stuff even works. I labeled all the spaghetti wires coming from the board and grabbed an iPad body, which, my god, look at that dust. But I put everything back together. Really, all we need to plug in is the 30 pin for power and the glass. And then definitely on the first try and not a day later after fixing some implementation bugs, it actually worked. It's so cool. This was so incredible to see after spinning for so long on this stupid problem. But that's basically phase 2 finished. Now for phase 3, showing an image on the display. Okay, so the adapter board doesn't fit where I think it should go, so what do? There's an easy solution to this that you probably already see, but that's not what I did first because I like pain. First, I considered some sort of extension cable over to the screen positioned where the current connector was, but that would require precise measuring and flexible PCB manufacturing, and I don't think so. My next thought was to inject the video signal onto the board directly. That way, the original connector could be used, and for bonus points, I could use the PMU I already have control over to drive the backlight, avoiding having to implement this backlight circuit with this expensive chip at its core. Of course, there were a couple problems with this. First, while it is possible to turn the backlight on with PMU over I2C, this is how it does it for the dead battery logo, the PMU actually has a separate bus for controlling the backlight amount for some reason. I tried to decipher what this bus was doing, but I have no idea what's going on here. So I was prepared to concede backlight control, but I still had to get the video signal onto the iPad board. Now there are no test pads that I can find for the DisplayPort signals. So there I was, soldering wires to 0201 capacitors. I needed to solder 11 tiny wires with horrible, fragile soldering. But then I had another idea. These passives are spaced 0.5 millimeter apart, and I have these little connectors I can attach to the pads. The passives aren't super necessary, and their functions are probably already handled at the source side of the DisplayPort connection anyway. I painfully soldered the connector down, grabbed all of the signals, and then I realized I'm stupid. What if I just turned the screen 180 degrees? That would put the connector down in this corner, which means the board could live right here, which means all the plugs could be on the same side. I just need to take the battery out, which we don't need anyway. So I removed the battery so the screen would actually fit in there with the board, and I think that's it. I think that's phase 3 complete. I was worried that was going to be much more complicated. But let me tell you what I'm actually afraid of. Phase 4, making it work with a computer as a multi-touch input device. So it already looks like it works as intended with this video clip, but this is just parsing my very verbose human-readable serial output. We want the touches to be processed by the operating system. And for that, we're going to need... Or maybe not. There's a standard for human interface devices called the USB Human Interface Device Standard. It covers a whole host of device types, pun intended. Basically, if we make the Raspberry Pi Pico a USB HID multi-touch device, it should just work. And like, how hard can that be? It still doesn't make sense. It sometimes works perfectly in Linux, but sometimes it completely crashes the desktop environment. And in Windows, it only registers one point of contact, which Windows should be easier. There's so much documentation for this feature stemming from that interesting time in Microsoft's history when the future was completely touchscreen. I mean, I literally copy and pasted their report definition from MSDN, and it still doesn't work. Never mind, I figured it out. USB HID descriptors are kind of sort of easy to understand, but they're also kind of hard to read. Let me show you. During USB enumeration, the Raspberry Pi Pico will say that it's an HID compliant device, so the host will be like, okay, cool, so what can you do? And the device returns this large blob of data that defines the contract between the host and the device. This first part tells the host, this is how you can ask me for how many touches I support. This was what was required for Windows. I guess Linux can infer the number of touches from this next part. This is the definition of a finger. Right now I've only implemented the required fields, but maybe by the time this video has come out, I'll have added more. No promises. I do accept pull requests, though. We repeat that structure 10 times because we support 10 fingers, and then we provide a number of how many fingers are currently touching. And that's it. As long as the data we send matches this data structure, all computers that support multi-touch, so ironically not Macs, will be able to do this. Okay, so we're closing in on the final steps now. We have all the pieces of the puzzle. Now we just have to assemble the puzzle and maybe add a little pizzazz along the way. For example, wouldn't it be cool if the touch data went through the 30-pin connector? It'll also be nice to just start from scratch and go from start to finish to clear away any cruft from the process, document it, and have a beautiful, fully working... First, again, you gotta open the iPad. I tried to use the iFixit opener this time, but I ultimately had more luck with hot air. You have to work your way around the bezel using heat and a plastic pick or something to loosen the adhesive. Eventually, you'll carefully remove the glass, and then a few screws later you can remove the screen, unlatching and unplugging it here. Then you can unlatch and unplug the glass. Removing the logic board is a few screws and a few connectors. Then you can remove the battery, carefully jamming a tool underneath to cut the adhesive, and then you remove the speaker. So when you've plugged the screen into the board, you can test fit it and kind of see where it's going to go. And that's roughly where you'll want to cut. Right, you want to cut this chunk out so that this nestles in correctly, and you want to go back as far, maybe a little bit further than the DisplayPort connection. Basically looks like that. Now it's time to look at the logic board. On the non-A5X side, pop off the two big shields and remove this sticker revealing the places we'll need to solder. We'll remove this component to physically disconnect the USB lines from the A5X so it doesn't do anything funky with the data lines, and we will just start soldering. Then we can glue the wires down with some UV glue to strain relief it, and then rinse and repeat, rinse and repeat, rinse and repeat. You should end up with several wires coming from several test points, ideally each with labels because it gets confusing really fast. And then it's time to reinstall the logic board and put in the Raspberry Pi Pico. First, you solder the data lines to the test pads underneath the Raspberry Pi Pico, then flip it over and solder the rest. At this point, we can upload firmware over the 30-pin connector, and... yeah, nothing's happening. I will debug this. Ugh. There are only two things different between this and my development setup, so it's gotta be one or both of those things that are keeping it from working, right? First, I was messing around with the power button, trying to integrate that into the mod, but it thought I was holding the button down forever, and I'm not sure why, but that was confusing the iPad, putting it into a boot loop, so I just kind of disconnected that, and then hit the second problem. The data lines of the iPad were now disconnected. The PMU wasn't aware that it could pull enough power to start, and in the absence of a battery, probably decided to show the dead battery logo or something. We need the iPad to boot to train, so how do we convince it that it can pull enough power? And being the USB noob that I am, I thought that I could just short the data lines together and it would figure it out, but no. Apple devices require the data lines to be held at 2.7 volts to indicate that it can fast charge.
Okay, how am I supposed to make 2.7 volts?
After poking around the board for a bit, I found 2.8 volts on a test pad, figured that was close enough, and soldered a wire from that pad to the data lines, and it actually worked. So I put it all back together. The glass, for some reason, no longer sat flush with the body, probably because this glass is from a different body, and this body had some damage, especially in the corners where the glass sits. But that's okay for now. I polished off my numerous fingerprints, and then gave it a test drive I thought was appropriate. So this is a Microsoft Surface. I think it's a Surface Pro 3. It's clearly missing its screen. There's no hard drive in it. It's a mess. Luckily, it doesn't matter. Woo! So here we go. This is more or less the final product, with all of its imperfections, granted. But here it is. It's kind of cool. Obviously, touching works. Multi-touch. In Windows, you have to kind of put all 5 down at different times if you have the gestures enabled. This is Windows 11 IoT Enterprise, so it doesn't come with pretty much anything. But Paint is actually... this is a picture I took, and I thought that maybe I would be able to, like, pinch to zoom, but it actually just draws 2 things at the same time. So, like... Ooh, that was weird. Is that a gesture? Ooh, I don't know what I'm doing. I don't use Windows 11, if you can't tell. Okay, so it's 4 fingers to swipe across desktops. That's kind of cool. And up. Ah. So one thing that's interesting, and I don't know if you can... Oops. I don't know if you can tell, but it's not exact. But if you watch it, it is always off by the same amount. And I'll bet you it's off by the same amount that the screen is misaligned. I didn't realize this when I put it in, but the screen is misaligned. By turning it 180 degrees, it just doesn't look... It just isn't right. I might be able to calibrate this. Let me Google it real quick. I'm gonna plug a keyboard into this poor USB hub here. Also, for what it's worth, this flash drive has the Windows to Go copy of this. This is running completely off the flash drive, so it's not only janky, it's also incredibly slow. But now I should be able to run tabcow.exe. Oh, that's so tiny. Okay. I might just be making it worse. Did that help at all? Or am I just, like, used to it now? Oh, that actually might have helped. Quite a good deal. The dot does seem to be under my finger more. Like I can't even like move my finger out of the way for you to see it. So actually that might have helped. Well, there you have it. A completely working multi-touch system made out of an iPad using the original glass, reusing as many parts as possible, including the screen and the logic board and, you know, as much as we can. Otherwise, what good would this iPad have been? It's iCloud locked. There might be a process to get to fix that. I don't know, and right now I don't care, because this is really cool. That's delightful. Finally, the project is complete. It took a little longer than I would have liked, and there are still some things that I think could be done to improve it. First, 3 cables is a lot. It might be possible to power the driver board with the same 5 volts that powers the Pico. It might need too much power for the backlight, but the option is theoretically there. Or if you're feeling really spicy, you can smash all of this into one board that does power, data, and DisplayPort alt mode over USB-C. 1 cable? Kinda sexy. There's also a serial port on the driver board. Maybe the Pico can issue commands to control the backlight? Could be interesting. And you can also put in some more effort to integrate all of the buttons into the system. It was acting weird for me, so I gave up for the sake of time, but wouldn't it be cool if the volume buttons on the iPad controlled the volume of your computer? And finally, we used a lot of the iPad here. The screen, the glass, some parts of the logic board, but there are other parts. Something to think about. The easiest one to reuse is the speaker. I mean, they're just speakers. The next easiest is probably the NAND. Strange Parts did this with an iPhone, so like, it can't be that hard. And then there's also the battery. I know the Ask Electronics subreddit says, don't make a battery pack, but if you're ignoring that warning because of knowledge and not arrogance, it's worth thinking about. And of course, the iPad has 2 cameras. They run over MIPI, which is a closed standard, but if you're motivated enough and you have a stack of iPads with 2 cameras apiece, maybe. Even though I now understand why Sisyphus was so glum, I enjoyed the project. It's more than keeping it out of the landfill. It's about extending the useful life of the parts, even if the whole itself isn't useful anymore. These old devices aren't worthless if you're creative enough. The brave little toaster really messed me up as a kid. But yeah, there you go. If you liked what you saw, go ahead and like, subscribe, tell a friend. If you want to do this, I mean, let's be real, you're probably better off just doing the screen part. But if you want to do the touchscreen part too, all the firmware and stuff is down in the description if you want to go down that route. Good luck.